Hello, I'm going to be talking about a non-homogeneous linear system of ODEs. It's like problem 5 in your web work set 18. And it's of the form y prime equals ay plus g of t, where a is a constant matrix and g of t is a non-constant function of t. All right, so the technique for this is a lot like a second order single ODE. We're going to have y vector of t, that solution is going to equal yh of t plus yp of t. So a solution to the associated homogeneous equation, which we've been studying for a while, or the form y prime, is ay. And then one particular solution to the non-homogeneous guy. All right. So we need to solve y prime, or dy dt, is ay. All right, and there's the a. So we need to find the eigenvalues and eigenvectors of A. Okay. All right. By the way, so this has general solution YH, or YH is a general solution to the associated homogeneous equation. So let's find the eigenvalues. Determinant of A minus lambda I is that thing for the determinant, minus lambda, minus 3 minus lambda. So I subtracted lambda from the diagonals entries, and I leave the other ones put. And that's going to be negative lambda times negative 3 minus lambda minus negative 2 equals 0. Right? So that times that minus that times that. So let's put the lambda squared first. Lambda squared plus 3 lambda plus 2 equals 0. This factors, and if it doesn't factor, you don't know it's wrong, but you kind of suspect, especially with the web work problem. Lambda plus 1 plus 2. Yeah. All right, so 2 plus 1 is 3. That comes in the OI part. And then the last is 2. OI and FOIL, right? Okay, so we have lambda 1 is negative 1, and lambda 2 is negative 2. You can name them the other way around, but it's pretty natural, right? So now we find the eigenvectors. For lambda 1 equals negative 1, we have a minus negative I times V1 is got to be 0. In other words, a plus I V1 is the 0 vector. So I add 1 to the diagonal entries of A, I get 1, 1, negative 2, negative 2. And I'm going to call V1, I'm going to call it a B just for the general. The components, I could be using subscripts, but this is nicer. And that should be 0, 0. And as always happens in this kind of thing, the two equations for A and B are redundant. So I basically just get A plus B is 0, and then I get minus 2A minus 2B is also 0, but that's just the same thing. So B is equal to, right, so this isn't needed. B is equal to negative A. Therefore, B is negative A. A is anything but 0. So I'm going to choose, let me see. So I'm going to choose V1 being 1, negative 1. Okay, or if you want, you can be ornery and say V1 is, square root of 14, negative square root of 14. You can do whatever you want. except for 0, 0, which does solve this, but v equals a 0 vector is not allowed. All right, so let's see. I think it's time to get rid of some stuff. Let us start to accumulate what we've gotten. We have lambda 1 equals -1, and at least our choice for v1 is 1, -1. And then lambda 2 is -2, and we don't have v2 yet, but we'll get ready to do v2. Now let's do we don't need the eigenvalue computation anymore. The eigenvector, let's just get rid of all of this. The eigenvector has a minus lambda 2I v2 is 0, and that's going to be a plus 2I v2 is 0. I'm going to add 2 to the diagonal entries. I get 2, 1, -2, add 2 to -3, get -1. And then I'm going to call this again AB. And that should be 0, 0. All right, so we get, therefore we get 2A plus B is 0, and the negative of that equation, -2A minus B is 0. Don't even have to worry about that. So here we get B is -2A. Again, A is anything, and I choose A is 1, and so I get V2 will be 1, -2. All right, so I can, all right. So now I'm ready to write YH. I write YH. The solution to homogeneous, associated homogeneous, is C1 e to the 1, lambda 1t, that's just minus t, times 1, -1, plus C2 e to the minus 2t e to the lambda 2t, times 1, -2. All right, and then web work actually wants it of this form. I hope I have room here. C1 times e to the minus t, negative e to the negative t, plus C2 times e to the minus 2t, and -2 e to the negative 2t. All right, so we'll need that. We'll have to add that to YP. Okay. We actually don't need to write this all down because when I go to the general solution, just looking at this will be enough, but web work does ask for these two vectors. Okay, so let's do now YP. Well, YP. Well, there is a method of computing what YP is that I haven't really told you about, but it leads to, it's really hard work, and it leads to integrals that you usually cannot do the integrals in closed form unless the method of undetermined coefficients works. So we have the method of undetermined coefficients for single second order ODEs or single 35th order ODEs, any single linear non-homogeneous ODE with constant coefficients with a special right-hand side. And anyway, well, that was basically, you guessed the form. And here, the web work tells you, gives you the guess for this form. We'll do the same thing with systems. We guess what YP looks like with undetermined vector coefficients, and then we plug them in and see what those vectors have to be. And in this case, they give us a hint that is A vector plus VB vector T. Okay, that's because this G of T is of the form a constant, 0, 1, plus another constant, 0, 2 times T. So this has the same form as the G of T right-hand side. Or, I mean, we didn't actually, the non-homogeneous part, it's not the right-hand side anymore because this is also on the right, but okay. And also, if I plug this in, or not, if I plug this into the to this part, I don't get a solution to this. I don't get a solution to the homogeneous equation if I plug that in. So the same thing happens. You sometimes have to multiply your first guess by t, but we're not going to go through all that. You will, if you ever get tested on this stuff, you will be told, given the hint of what the form of the particular solution is. All right. So we're going to take this where A and B are undetermined vectors. Vector coefficients, like the undetermined coefficients before, but now they're vectors. Okay, well, let's see. What is YP prime of T? That's just B. Okay. So plug this into the differential equation with the G of T part, and you get B is equal to 0, 1, -2, -3, okay, times A plus BT, okay, plus 0, 1 plus 2t. Okay. So this has to hold for all t, right? So that's an equation of two functions of t, and the first component and the second component of this vector-valued function of t have to equal each other. So I think we should probably put in some coefficients here. Let's let A be A1, A2, and similarly B be B1, B2. So let's write this thing out here. I mean, this is kind of a slog, but it's doable. So this vector becomes B1, B2, and that is equal to 0, 1, -2, -3. Now this is the vector A plus BT. The first component is A1 plus B1T. The second component is A2 plus B2T. And then that plus 0, 1 plus 2t. All right, so I think we're ready to figure out what these four coefficients, A1, B1, A2, B2 are. I'm going to erase this. As I said, we can remember that. And actually, I can erase all of this. Let's leave this part here, because so we remember what the A and B mean. But let's write out this equation. I'm just going to do the first component and the second component and not bother to write it as a vector. So B1, the first component, is, I have to do my little finger motion to do the matrix multiplication. 0 times that, plus 1 times that. That's A2 plus B2T, okay, plus 0. So that's the first component. The second component is B2 is, this is a little bit more work, negative 2 A1 plus B1T minus 3 times A2 plus B2T plus 1 plus 2T. Okay, so I'm going to call this equation 1 and equation 2. And it's not really very original, but okay. So what does equation 1 say? Equation 1 says that, well, that B1 equals A2 and 0 equals B2, right? The constant terms on both sides have to equal, and the coefficient of t on both sides has to equal, because this is an equation that's got to be true for all t. Right? I know sometimes we see an equation like that and we solve for t, but no, this is an identity. This equation is true for all t, and that's only the case if B2 is 0 and B1 is A2. Okay? So in fact, let's just, this is, I mean, I wrote 0 as B2, but that's really B2 is 0. So let's write 2 with what is it? Let's just get rid of the B's. Let's just get the A's here. So with A, we're getting rid of the B's. B1 is A2 and B2 is 0. That says, okay, let's put this thing. Okay, B2 is 0. Is that right? Yeah, that's what I said. Cool. So that says that 0 equals negative 2. Okay, we're keeping the A's and getting rid of the B. So this is A1. Okay, plus B1 is A2 T minus 3. A2 is just A2. But B2 is 0, so I close that up. Plus 1 plus 2T. Okay? All right. So let me see. Maybe I should circle what I've already known. And I'll get rid of this. All right. So let's simplify this a bit. I get 0 equals. Let's combine all the things that don't have t's in them, and I have minus 2a1 minus 3a2. Oops. I took care of that term and that term, and I also have plus 1. I took care of that term. And now let's get all the terms that have t's in them, and let's let's group them together. So I get minus or negative 2a2 times t plus 2 times t. Okay? So I took care of this guy here, I took care of that guy there. So I've taken care of everything. And so we have to have the constant is equal to 0. And we've got to have the coefficient in front of t has got to be 0. So I'm going to start with this one here. This is pretty easy. That means that A2 is 1. Let's circle that. Okay. And then if I put A2 equals 1 over here, I get negative 2 times 1 minus 3 times A. Oh, no, I don't. I'm looking for A1. It's A2 that's 0. So negative 2a1 minus 3 times 1, which I leave out, plus 1 equals 0, or that's negative 2a1 minus 2 equals 0, or A1 is -1. All right. Whew, so I got all the A's. Now that I know that A1 is -1, I know that's also B1. So maybe I was a little bit premature to circle this guy here, because that doesn't really tell me what A1 or B1 or 2, what A2 or B1 is, just that they're equal. All right, so now I'm ready to do this YP. This A is actually A1, A2, -1, 1, and B is B1 is -1, B2 is 0. All right, so that means, put that together, I get that YP of T is A plus BT. So I get -1, 1 plus -1, 1 T. Okay. No, it isn't. That's a 0. I'm also kind of wondering, let's see what I got here. And I did this. B1 is 1. Yeah, I get B1 and A2 is 1. Oh, yeah, B1 is A2. This is not right. That wasn't right. B1 is A2. So this is B1 is 1. So I screwed up. B1 is 1. Okay. Whew, I think I got it all here. So I might want to also rewrite this as -1 plus T, or kind of nicer, T minus 1 and 1. Right? So that is what YP is. All right. So now I've got YP, and I've erased YH, but we know exactly how that works. Nobody said this was easy, but there's only 5 problems on this. All right, so that means the general solution is YH plus YP, which is Y of T is equal to C1, okay, e to the minus T times 1, -1, plus C2 e to the minus 2T, 1, -2, plus T minus 1, 1. Oh, whew, okay. So that means that Y, right? So now I'm doing the typical thing. I found a general solution, and sometimes I'm done. But here I have an initial condition, so I got to plug T equals 0 into this, and set that equal to 1, 0, solve for C1 and C2, and plug them back in. So let's, that was a vector. So let's figure out Y of 0. From the formula, I get C1 times 1, -1, because e to the 0 is 1. I know that without a calculator, and hope you do too. Plus C2 times 1 times 1, -2, plus T is 0, so that's a -1, 1. And I'm going to set that equal to 1, 0. All right, so cool. So that means that the equations are, first component is C1 minus C2 minus 1 equals 1. The second component is -C1 minus 2C2 plus 1 equals 0. Okay. And that's a plus right there. C1 plus C2, okay? All right, so let's put everything together. We have C1 plus C2 equals 2, adding 1 to both sides. And here, I'm going to pull this to the other side and multiply through by -1 and get C1 plus 2C2 is equal to 1. Did I do that right? That became a -1 when I pulled it over, but then I multiplied through by -1. All right, good. So we have these two. I'm going to call these again 1 and 2. It's maybe not the most natural name, but I can solve this by taking second equation minus the first. Second equation minus first. These guys cancel, and I get C2, 2C2 minus C2, just C2, equals 1 minus 2 equals -1. So C2 is -1, right? And now that I know that C2 is -1, I'd probably plug it into 1. 1 gives C1 plus -1 equals 2, or C1 is 3. All right. So now with the magic of whiteboards, I'm just going to take the general solution and replace C1 by 3 and C2 by -1. Okay, so that is the solution. That is the IVP solution. There's the solution to the initial value problem. Okay, so again, to enter this answer into WebWork, I've got to write just the two components. And I get y of t is, what's the first component? 3 e to the negative t minus e to the negative 2t plus t minus 1. And then I get -3 e to the negative t plus negative is a plus 2 e to the negative 2t plus 1. All right, so I should probably at least check that it satisfies the initial conditions. When t equals 0, I get 3 minus 1 minus 1. 3, yeah, I get 1 on the top when t is 0. And on the bottom, I get -3 plus 2 plus 1, I get 0. Yeah, satisfy the initial condition. And I can see my particular solution poking out there, and I can see C1. I can see I can just see that it satisfies the differential equation. All right, let me check. I'm pretty sure that's what I got before I practiced this one. I tell you, you'll probably take a little bit of time to get it out. Right, yeah. I got it right. Whoopee! All right. So this is actually the last problem, last WebWork problem of the whole semester, except for the WebWork tests. Oh well. Okay. Bye.